Hello friends. After the end of this video, you have a clear understanding of linear regression under supervised machine learning algorithm. But I have not just used only Python. In fact, I went one step ahead by making use of Django. Not only that, the linear regression I'm not using sklearn package. Instead, I have done the complete numerical by myself, and I will explain this so that you have really a good understanding of how exactly the very first machine learning algorithm, that is called linear regression, is going to be implemented, because thereafter you will come across different more algorithm. So this is like a hands-on and a very strong foothold toward the implementation of machine learning. So let's move on to the code part right now. I have got my Django application. Here is my project, linear regressions custom, and I click on the media folder. There's nothing inside. Rather, what will happen is when I will run the application, dynamically the image will get generated, a particular image will get generated inside the media folder on the fly. I made use of AJAX for taking the asynchronous communication, hence to prevent the page load. Inside the template folder, I have got few HTML pages, and this is the page that will be responsible for taking input from the user. Well, let me run the application first and show you how exactly it's working. So the server is on right now. Let's minimize this. Let's go to the terminal, the browser, and I hit the enter, and the application comes right over here. As you can see, there are a couple of forms. One is for X and Y input. This is like a data set which I will be providing. Based on this, my program will create the equation of the straight line. So once the equation gets implemented, I will just pass the X, and it will provide me the predicted output in the form of Y. Now you must be wondering, what is this X and what is this Y? Well, X represents the independent variable, or you can call it even as a feature or input. Like for example, let's consider the number of hours I study. Okay, so that will be the X. And what will be the Y? The Y is the dependent variable, or you can call it even as target or output. The Y would represent my growth. Okay, so consider this: number of hours is my input and the growth would be the output. That's how the data set will be formed. Okay, so once the data set has been formed, the equation will be created, and then what will I do? Well, this equation will be represented in the form of an equation of straight line, because we are working on regression. So for that reason, we will be getting a best fit line. What do I mean by best fit line? Don't worry, I will explain. And once the equation is created, then I will just supply the X and not the Y. Putting the X inside the equation, it will generate me the predicted Y value. Okay, that's the reason why you saw over here there are two forms. So this is the form for taking X input and Y input. This is for the training data, and once it is done, and then we will have the only form that will take X and it will predict me the Y value. And over here I have got the segment where the image will be generated dynamically. So let's start the process. I will provide the input over here initially in the form of like suppose I'm giving the input as 1, and if my hour of study is 1, I will be getting a growth rate of 2. That's what I'm considering. I hit the enter. Well, as I do that, it says at least 2 data points required for the regression. So let me give the value as 2. I'm studying 2 hours. I will be getting a result of a growth of 3. The moment I do that, immediately you see the image getting populated, which was not there. So this image shows you an equation right over here. So how come this equation get framed? Great. And that brings us to this numerical, which I need to make you understand first, that how exactly this is working. So let me zoom it a bit. So as I said, X will be my input, which I will be giving in the form of number of hours, and Y is the growth that will be getting generated. Okay, so I have given only couple of input in the form of 1 and 2, and I also have given the Y value. I will be giving few more so that my equation get framed. So let's consider that I will be giving 3 hours, the growth will be 5. I will be giving 4 hours, the growth will be 7. I will be giving 5 hours, the growth will be 11. So once I have done this, now comes the complete equation I will be generating. So how is this equation will be getting generated? Well, we have to do some summations of these following columns. So first I will do the summation of my input X I will be getting the value 15. Summation of y, that is my growth, I will be getting the summation as y over here. So this is my independent variable and this is my dependent variable. Then I will be going for the product. So the product will be this and the summation of the product, and then I will check how spread my input is, or in case if there is any negative input, that will get eradicated with the help of x square, and finally there will be summation of x square also, and total number of data point I have taken as 5. Okay, now I'm going to generate the formula of my equation of straight line, that is called y equals to mx plus b. So the y will be my predicted result, which initially I am giving, but once I have got this data set, once I have got the equation, I will not give the y, I will just give the x, and putting the x value inside the equation like this one, which we will be getting. So here I will be giving the x input. Once I have this equation, it will be predicting me the y value. Okay, so before I get into the equation, y equals to m. So how do I get the m? M is the slope, and here comes the formula. I just need to put the formula data from here. So n is the number of data point, that is 5, into summation of xy. Xy is this one, 105. 105 is this one, 105 is over here, minus summation of x is my input, summation of y is my over here I put, divided by, again number instance 5, into summation of x square. X square is 55, that I put over here, minus summation of x whole square. So x, summation of x is 15, whole square is this one, and once I do that, I get the value of m as 2.2. Great. So now I will go for the intercept, and for the intercept the formula is summation of y minus, so y is how much? Y is 28, I put that, minus m, which I just now calculated, that is 2.2, into summation of x, and summation of x 15. Once I put that, divided by number of instance, I will be getting the value as minus 1. And now I have the final equation, that is y equals to mx plus c. So m over here is 2.2, x, which user will be giving later on, and that is mx plus c. The plus c over here is minus 1, that what I put. So this is the final equation that I will be using for generating my resultant output in the form of y predicts. That's what I will be doing right over here. So this entire equation numerical which I have solved, I have to do this entire thing into the code. So let me take you to the code part right now. So once the input has been given by the user in the form of this form, where x and y I will be giving, I will be passing on this data to AJAX, and from AJAX it will come to the Django, and over here I have a URL, and this is my function based view. So let me take you to the function based view right over here, and what I'm doing is that I have got to empty list, as we just now saw in the equation that I need to have the x and y. So for that reason I need to have the x and y, which I just did over here. Let me put it over here. So x as will be represented by this empty list, y will be represented by this empty list, and for the equation I will be getting two variables, m and b. Now what I'm going to do is that I'm going to use over here two different forms, because one form is representing my input, that is data set, and the other one will be my predicted output, right? So right now I've just given a couple of inputs, so let me complete the process. As we just now saw, I need to give the input as 3, that is the 3 hours of study. I will be getting a growth of 5. So let me give that 3 hours of study, I will be getting the growth as 5. I hit the enter. That what gives me the equation. Again the equation is getting modified. See, I give 1, the growth was 2, I give 2, the growth is 3, I give 3, the growth is 5. And now what I will be doing is that I need to go and provide the hour as 4, I will be getting the growth as 7. 4, I will be getting the growth as 7. I hit this, great, 4, I get the 7, and finally I will be giving the number of hours as 5, I will get the growth as 11. So number of 5, I will be giving the growth as 11, and once I do that, my equation is done. So this is my final equation, that is 2.2 x plus minus 1.0. So if you see my equation, that is what exactly I got, isn't it? 2.2 into minus 1, that's the equation I got, and this entire numerical I have solved right over here, and that too using the NumPy, using the Matplotlib. Well, NumPy would be helping me to do the direct summation, so that I don't have to go for iteration if I was just using list. So for that reason I typecasted I typecasted it into a numpy array so that I can use these 4 mathematical evaluation which I did over here. So this is my summation of x, which is my input. This is my summation of y, which is my output. This is the product of x into y, and this is the spread across of my input, and that is summation of x square. So x square will be represented by x double star 2. That's how these 4 summation result I got, and finally I plotted it into this particular slope, and from there I got 2.2, and then I just plotted the slope value into the intercept, and I got -1. And once I have that, I created the equation. This is the equation which I'm just sending it to my front end. Again, the front end will be my AJAX. Through AJAX I'm going to display the result, because there will be no page load. And as you can see over here, what Matplotlib is that it created a image. Matplotlib created the image, and that image got stored inside the media folder at the runtime, because when I started there was no image at all, and that's what we saw right now. So if I click on this, this is the image which we are seeing directly in the HTML template. Isn't it great, right? So this is all that is happening at the time of training the data. So once the training is done, now I can go for prediction, because I have my equation ready. So now if I go for prediction, what I will be doing is that I want to put a predicted value over here in the form of 6. So if I put a 6 over here, what resultant output you will be getting? So 2.2 into 6 minus 1, that's what I will be getting, and I want to see what would be the resultant output. So I'm just providing the input as 6. So 6 is the number of hours. I want that the system should predict me what would be my growth. It is the last value. So let me click on the button. As I do that, look over here, when I go for 6, my growth will be 12. That's really awesome. So 12.2, I have rounded off to 2 digit, so 12.2 is what I'm getting. Isn't it great? So that means it has shown me right over here that if my investment is 6 hours, my growth would be 12, and this is actually coming from this equation, and this is what exactly the linear regression does. So initially you have to give a data point so that it creates an equation, and once it has the equation, I will be taking the x input, and that's what I'm going to plot in my equation so that I get the resultant output. Bingo! Great, isn't it? I really fell in love with doing this particular program, and see this how neat and clean. I've seen many videos where the person has just gone for Python, but do you really think you will be able to implement that in real life unless and until you transform it into a web platform, something like this? And not only that, I have a future plan that I will be implementing this in a form of a REST API, so that why not the data comes from the Android or can become from React, and then this entire data point will be forwarded back to the front end in the form of Android or even the React. Really awesome. Okay, now if you notice over here, well, my topic of discussion is almost done, but before I bind up, I just want to tell you one thing. Then look over here, the best fit line is actually not touching the exact points which I have given, and that's the reason why this is also known as ordinary least square, because what the best fit line is trying to do is that it is trying to find out the best fit so that it can connect to the data point. Connecting means it will not touch all the data point. So there is some pointer above the best fit line, some pointer below the best fit line, and that's the reason why there is some deviation, and this is what called residual. This is the error that is actually getting generated. Okay, so as you can see over here, when I give 1, it should have been, according to that equation at that point of time, it would have been like 1.2. I saw that it would have been 1.2, but the best fit line has slightly deviated from there, and it is showing me I have given the value 2, which was not actually correct. It should have been 1.2, but the best fit line has tried all possible way to generate the line in the form of a straight line so that it can reaches the closest data point. So there will be some data point below, some data point will be up, and that's where the residual segment comes in picture. That means this is the residual error of a given data point. Okay, and you can even figure out how much is the residual with the help of the squared error. You can figure out that, but nonetheless that's something, a different topic of discussion. But overall what I understood from this is that equation of straight line in the form of supervised machine learning in the form of linear regression has been really amazing. Well, I have even thought about going for the next algorithm, that is a logistic regression. Well, in case of logistic regression, there is no straight line because we will be working on probability. So over there we will make the sigmoid function. Sigmoid will be the way it will be represented. That again going to be really interesting, I believe, and I will really work on that. But from this particular video presentation, I made you clear that if I'm really implementing a hands-on numerical operation like the way I did over here and the way I did the prediction over here, you really don't need the linear regression from the sklearn. But of course this is the best way also to do, because here I've done so much of coding that what you don't need to do in case if you directly implement that. But I believe what is happening under the hood is that what I have shown you. So if you have gone for a sklearn model, then you just need to take the input from the user, like what I have done over here in the form of x and y. This input which I have taken, after you have taken that x and y, you are going to put that into the function called fit, and once you have done that, the model gets generated, and once the model is generated, you have now to pick up the coefficient, and you have to take the intercept, and then once you have that, the model also provide you a function called predict, where you will be getting your input, that the one which I have given right over here in the form of 6, and it will provide me what exact the predicted output you are going to come across. So that is what I did in this particular program, and I've transformed the linear regression into Django, and I believe you people definitely enjoyed this video. Okay, so let's see in the next video where I will be working on logistic regression. Until then, have a nice time. Bye bye.